Good morning, everybody. My name is Mike Donovan. I'm here today for the TEMA conference to talk about airborne and surface pathogen or contagion mitigation strategies for going back to school, for going back to educate all of our children and for our teachers and our staff. HTS is a full-service HVAC classical rep, manufacturer's rep, as well as a service, low voltage controls and security, as well as parts distribution. We are very blessed. We do business with a lot of TEMA members already. We've been here for 18 years. We have roughly 300 employees in Texas and 1,100 employees in US and Canada. As you can see, I've been a big part of ASHRAE, has been a big part of my life as a volunteer and trade affiliation. I've served the Houston chapter, gone through the chairs. I've also served the region and serve the national board as well, more in a research designation capacity, where we take the monies raised from ASHRAE research and we dole it out to the universities to conduct research on things like IAQ or energy or whatever. Local to Texas, I grew up in Houston and I went to Texas A&M and got a chemical engineering degree. And I figured what better thing to do than to sell HVAC goodies. So today we're going to be recapping what we're all going through right now. We're going to take a little bit deeper dive into the SARS-CoV-2, talk some on indoor environmental quality, with indoor air quality being a cornerstone or a pillar of indoor environmental quality, and what's kind of current thinking, what's going on out there, and what are some of the publications that have been pushed out in our neck of the woods. And then we're going to talk a little bit about, what's ASHRAE's recommendations, as well as what the industry recommendations are in the conventional thinking and a passive filter. Then we're going to show a chart. We're going to evaluate, and this chart was developed in April, and I had a lot of help from a lot of manufacturers to help me with this chart. A side-by-side comparison of various filter, surface disinfection, airborne disinfection technologies. And then we're going to take basically the top three of those from that, and then we're going to look at those side by side and what those can do, for the occupant or for the facility in that capacity. And then we're going to talk about, okay, now we've either invested or purchased IAQ enhancement systems or products, regardless of the manufacturer origin. How do we know that they work? What can we do to monitor the air quality in the space, even if we don't decide to invest in any indoor air quality enhancements? So this is what we've been going through, ever since, really since January, but it really didn't hit home with us until about spring break. And that's always the joke is, we're on extended spring break, but it's not so funny for those that have children that've got to get back to school and are managing, now work and kids. But we've been dealing with, the social distancing, washing our hands, good hygiene, wearing masks. And we know all that, and that's been, beaten into our heads. But now we've got to go back to work. We've got to go back to school. The extended spring break is over. So the first thing we're going to do is probably clear out the old fridge. But really, there's been just a tremendous amount of information on go back to work strategies. Every property management firm has, done their own go back to work strategy. The CDC has, the WHO has. ASHRAE's really, near and dear to my heart, near and dear to our industry, because ASHRAE is basically the indoor environment, expert from OSHA and NIOSH, obviously, are players in that game too. But they released an epidemic task force document in the middle of July. It finally got distributed late July. And that's something that I can get you if you don't have already. But it kind of tells you step by step back how to, what ASHRAE's recommendations are for going back to school. So then we started seeing a bunch of information in the press. We're still seeing a lot of it where the HVAC system has a part to play in distributing the SARS-CoV-2 viral pathogens. But if you talk to most healthcare facility, even at the C-suite or at the facility level, they're still pretty hung up on it's coming, as droplets, from someone sneezing or coughing, and it's not getting in the HVAC system. There has been some recent research in Japan and Finland, and I know that ASHRAE really captured it in the last month's, in July's ASHRAE journal. And I could forward that article as well. And they called the article "Evaluating Virus Containment Efficiency of Air Handling Systems." It's a good article, and it's really the first article that kind of touches home for our industry as it relates to what are some of the things that we can do or look out for in order to contain this virus from one space to the other. But there really hasn't been a lot of what I'd call research momentum into the airborne transmission world. There's a lot of noise and talk out there on the internet that it's happening, but the CDC hasn't really embraced it and said it is. And so a lot of the presentation is going to discuss airborne control of pathogens, but no, it's really on the fringe, and it's getting a lot of research momentum to be evaluated. And this ASHRAE article was fantastic. It talked about ways to contain the virus in one room versus the other. So what do we know about the coronaviruses? And I say that because this is a long, history, once every other 6 or 7 years. And I only say that because not as Doctor's Doomsday, but because it's going to happen every 6 or 7 years. There's going to be some mutation of a pig, a cow, a horse, a bat, as relates to humans. And, these are the, basically the gyrations or the permutations or variations of what this looks like: MERS, SARS-CoV-2. The good news, and the reason that the vaccine has scaled up so fast, is because the SARS-CoV-2 virus is equivalent in the protein RNA makeup as a SARS-CoV-1 virus. So that's why we're seeing a lot of activity in the private and public research, as well as the private and public, manufacturing sector, to rush out and manufacture these vaccines pretty quickly, and to do all these trials, is because it's very similar. Typical vaccines, if we look at history, take sometimes 3 or 4 years before they're finally approved and vetted and and allowed to be distributed to the population. One thing that I ask everybody to be worried about is viruses that don't have a conscious or a protein, and so they're not a multicellular structure. They don't have a brain or mind, so we can't kill them. All we can do is infect them and activate them or make them inert. So be wary of anyone talking to you about killing a virus, because we can't kill something that's not living. So what is indoor environmental quality and indoor air quality? And then we're going to kind of look at it up here, and then we're going to go down here. Obviously, we're not going to be talking about acoustics and daylighting, which are some of the pillars in indoor environmental quality, but I know are important to all of us in an educational form. In our industry, we look at ASHRAE, NIOSH, and OSHA as basically the indoor experts on air quality, and we look at EPA as the exterior air quality experts. And the EPA measures ozone, particulate matter 2.5, particulate matter 10. And, in a city like Houston, probably at 70 different depots or monitoring stations, air monitoring stations. And you can go down to airnow.gov and you can, look at ozone and air quality all day long. It changes by the day, by the hour, and they regulate ozone, particulate matter 2.5 microns, particulate matter 10 microns. And that is an indication of the air quality in the city and whether or not you should go outside if you've got asthma or you've got respiratory issues. So you can find all that information on airnow.gov. But it's important to know that we're taking some concepts that have been known for years, and we're going to apply them now to the indoor space. So the middle of April, ASHRAE was really the body that came out and said, hey, we think this is an airborne scenario, and it can get around the airborne exposure. So this is just straight out of ASHRAE's statement. So, they said transmission of SARS-CoV-2 through the air is sufficiently likely that airborne exposure to the virus should be controlled, and should look at changes to your HVAC system. And then they said, hey, don't turn it off. Ventilation and filtration provided by heating by the HVAC system will reduce, good ventilation, good filtration will reduce the risk of SARS-CoV-2 through the air. It's not recommended to turn it off. And then, then obviously, which was interesting, is the CDC went to ASHRAE 170, which is the healthcare design manual, effectively. And they took this chart out of ASHRAE 170 and they shoved it into CDC sometime around late April. And it's really interesting that it was kind of a cut and paste. But what was interesting about it is that they're basically trying to apply, a healthcare environment now to every environment, as it relates even to the residential business. So this is ACH's air change rate. And then obviously you can read the rest, air change rate at time required for contaminant removal by efficiency. So the more air changes, then, the more chance you're going to have it controlling or controlling or mitigating airborne contamination of the virus. So what this chart doesn't tell you right here is 6 air changes. That's got a 2 by it, 2 outdoor air changes. So in a school, we're typically talking about 4 to 6 air changes and about 1 to 1.5 outdoor air changes if everything's properly set up. So we're somewhere in between 4 and 6 in a traditional school. Then during that April document, ASHRAE said, okay, what we recommend moving forward is, basically higher efficiency filters. Most school systems that we do business with use, MERV 7 or MERV 8 filter. And, they're basically, ASHRAE's like, upgrade that to a MERV 13 filter. It's easy for all of us just to say that, but to do that is, a significant amount of work. Sometimes, you might have only a 2-inch rack and there's only a couple manufacturers of 2-inch MERV 13s. And that may present a problem of supply. The MERV 13 filter is got a pressure drop that's almost double and more than double when it's dirty. So I don't know if you've got enough fan horsepower to push the air over this higher filtration system. Have you looked at the ventilation and building pressurization? Is it all back to when the school opened? Is it all commissioned? Are you getting the right amount of ventilation? We have some larger school districts that aren't going to upgrade their filters, but they've chosen to retest and balance all their schools to make sure they're getting the right pressurization and ventilation. So that's an idea too. And then implement gas phase biological contaminant removal systems. Initially, ASHRAE was very used UVGI and UVC as a mechanism to do that, but they didn't objectively tell any of us how to apply UVC or UVGI. And then that last epidemic task force did give us an objective measurement, 30 watts per square foot on the utilization of UVC systems. And it also said to use ionization as well, and then obviously maintain proper temperature and humidity levels. And I'm going to touch on that really in just one slide. But I'm going to really talk about the first and third bullets. So this picture, this particle settling in still air is interesting because this came out later in a CDC document in May, I believe. I might be getting some of my months, backwards or forwards, just because they're the COVID season. And I thought it was interesting because this picture was from like 1970 that ASHRAE had developed and starting to develop the 170 standard. Which is a healthcare design standard, but it really just tells us what, we've been talking about is the smaller the particle, the more time it's going to sit in the air. And in an average 1 cubic foot of air, there's 18 million particles in there, dust particles. We'll call it atmospheric dust. And so the smaller the particle, which is predominantly what's in that from a volume or number standpoint in that cubic foot of air, they're small. And we'll see what the industrial hygienists say in a chart later, but the SARS-CoV-2 averages around 0.12 microns. So it's a pretty small viral component, but it actually needs something to hitchhike on or transport with. And those particles are typically between 0.4 and 1 micron. But I thought this was interesting because, this is something that our industry's been known forever, and that's why the air change rates are so high in healthcare systems. So this is our current thinking. From our business: filtration, disinfection, ventilation, temperature, and humidity. So a quick word on temperature and humidity. This shouldn't be a foreign these things should not be a foreign picture to all of us. This is the ASHRAE Standard 55 thermal comfort envelope. And this is why we have thermostats set at specific temperatures in the summer and winter. And then this is what I call the mold and virus and bacteria humidity zone. And it just confirms why we keep things between 40 and 60% relative humidity in a space within these thermal comfort temperatures. And if we fall below the 40%, and there's a lot of research that suggests between 20 and 35% is an optimum environment for viruses to replicate, or bacteria and mold to grow and replicate, much more so than on the other side of 60%. And so we want to keep our humidity in that zone, right around, at least 35, 40% or higher. And then it also talks about, respiratory and allergy, asthma, as well as ozone production. So just a quick word that, this is why we keep our systems between 40 and 60% in the thermal comfort envelope. So we're going to talk about filtration, and when I'm going to go through filtration, I'm going to go through it pretty quickly because we all kind of know it. It's a passive filter is what we deal with every day. It's just basically a sieve, and the higher the MERV rating, the tighter the sieve. And it loads on its front face. It doesn't load 360 degrees. It loads in the direction of airflow, and as it loads, the efficiency starts to increase to a point of diminishing returns, but you're trading off that efficiency for energy consumption. I always say that if you buy a filter, the actual overall total ownership cost of that filter by the time you buy it and it sits and gets air pushed over it is probably 5 to 10% of actually what the filter is. So the filter cost is like 5% to 10% of what the total ownership cost is because of the energy it takes to drive air across it. But it's a necessary evil, so you could look at it, you can look at it both ways. But that's about the right figure if you're keeping score. The MERV rating is something that ASHRAE came out in probably the mid 90s to late 90s, and it basically got the playing field even for all the filter manufacturers, because filter manufacturers are advertising 85% efficient, 90% efficient, 30% efficient, and no one even really knew what they were buying. It just had this nice sticker on it that was like 40% efficient. And so they developed a MERV rating test with a company called Blue Heaven Technologies, and Blue Heaven Technologies is in Kentucky, and it's the MERV rating, fixture in the industry. But the way that these filters are rated is based on particle efficiency, so 3 to 10 microns, 1 to 3 microns, and 0.3 to 1 microns in each range. And keep in mind that, and we'll see it later, is that the human eye can only see about 30 to 40, maybe 30, really good side, but really about 50 microns is the biggest thing that we can see with our human eye. So all this test is with stuff that we just can't see, which is good because that's what, that's where the bad stuff is. Range, 3 is where, I always say the bird catching filters, and then range 2 and range 1. And we'll see why ASHRAE took that position, because down at MERV 13, it's saying on one pass, it's really 42% effective against catching the particles that small on the first pass. This is all one pass efficiency. So just to take a step back, we talked about air and how there's 18 million particles per cubic foot. When we were learning in school, we were always told it's 4/5 nitrogen and 1/5 oxygen, but there's a whole bunch of other stuff in there. So I wanted to show you just what's in the air and how many particles are in there. So if we look at this, using sports equipment like a basketball, and we go back to look at that settling rate, obviously the larger the basketball or volleyball or small basketball, then the faster it'll settle in air all the way to these pellets in this jar, this container. And this is what's in the air. But the biggest thing we can see here is this basketball. And then we take if we break down air, and it's 1 cubic foot or just this box, the the number of particles, 98% of the number of particles are smaller than 0.5 microns. So I mean, they're really, really small stuff. But the other 2% of the number of particles make up the weight and the volume of the air. But the number of particles in the air below 0.5 micron from a number standpoint is a lot. So, just think 17 million particles. So the American Society of Industrial Hygiene and Industrial Hygiene Association, this chart's been out here for a long time. I've used this chart actually for the last 8 to 10 years, just to show the folks that I'm talking to that all these particles are in the air that are indoor pollutants are small. They're very, very small, and they're smaller than what the filters we use can catch these things. And so they have to settle on the ground and get vacuumed up, or wherever they settle, they settle. Hopefully they combine and they go to the filter. But it is what it is, and they're really small. So just from a pictorial standpoint, we can look at the fine beach sand and human hair, and then what the EPA measures outside, 10 micron diameter particles and 2.5 micron particles. And that's what we know. And then if we look at what an actual SARS-CoV-2 size is, it's about 1/20th of that 2.5 micron. So it's something that we can even see if I showed a dot on a speck on the screen. But it does need a hitchhiker to latch onto, and that's the part of increasing the filtration, is to get rid of all the hitchhikers and transport vehicles for the viral to move around in space. So what happens to all those small particles that don't get caught by a filter, don't fall on the ground? So what happens with us when we're walking around space? Well, we have the filtration system too in our trachea and our respiratory system, all the way in our lungs, all the way to our alveoli. So we have a filter system that's filtering out that too. But what happens whenever bacteria or virus goes through our filter system? We end up getting sick. And so that you can see our own human filtration system and what it can detect and how it can latch onto our respiratory system. So when we took a look at Asher's position, this is a good first pass at utilizing MERV 13 filters. MERV 14 filters, if possible, they also come in 2-inch. Again, higher pressure drop, but the trade-off is they provide a cleaner space and get rid of those transport particles or hitchhikers more effectively. So we've seen an increase, obviously, in the interest of HEPA filters, and really, the HEPA filter is an interesting trade-off because it does require much more space. It's very invasive, and it costs a whole bunch of money, and then it costs a lot of money to ship air across the HEPA filter bed. But HEPA filters still, aren't, this be-all, end-all of air cleanliness in this scenario. And air has to actually get to the HEPA filter. I think it's just like MERV 14. It's a good step to continue to clean the air. But a lot of people are being thought that it's the only way to clean the air. And it doesn't really address what's going on in the space. It only addresses air that's coming back to the air handling unit. But again, it's another positive first step in the right direction of clean air. I've reiterated a lot of this in this slide. Is again, you're just with filtration. The higher the filtration, the better the first pass efficiency of getting rid of transport or transport particles or hitchhikers. It only addresses remediation in the circulated air. It doesn't do anything in the space. And one thing that we have known and we've seen for years is this 2-inch MERV 13 filter that you replace with 2-inch MERV 8. It loads up really fast, and it has a much higher pressure drop. So, the facility user will be, have more maintenance and more energy. So it's doubly, unfortunate in those particular categories at the expense of cleaner air. So this is a N95 face mask picture on the right. And so when we think about what we're going to do in the future, and we'll talk about what systems that we're seeing deployed the most towards the end of the presentation, but when we think about what we're using in the future is that in healthcare, and even initially here at HTS and all of our offices, we're giving out everybody N95 masks to wear. It's basically a 5 layer filtration system. It's hard to imagine it's such a thin layer, but there's 5 filters in there. And it addresses air purification and small particle capture. But this is how we think of filtration and all these different steps, VOC reduction, particle capture, ultrafine particle capture, disinfection, surface or airborne inactivation or kill if it's a bacteria or mold, odor and smoke removal. So there's a lot of things we think about, and we're going to, and I'm going to address those when I bring this chart over in a second. So whenever we started this in late March, we represent a variety of more, we're not in the mainstream filter business. That was never part of my dream to be a filter salesperson. And so, but we're into more air disinfection, air cleanliness technologies, and we represent 5 different ones. So we're pretty agnostic about which way, someone wants to go with the conversation. But there's UV lights, there's higher efficiency filtration, which you see over here. There's needlepoint bipolarization systems, carbon filters, photocatalytic oxidation, and then electronically enhanced filtration. And the one thing that I'm not going to touch on today is the emergence of these hydrogen peroxide generators. And the caveat is why I'm not touching on those is they haven't been deployed for near as long as these other technologies. So I'm being from Texas and being in this business forever and how conservative we all are. We typically like something that's been around for 15 or 20 years before we're going to try it in our backyard. But I do see some of the advantages and highlights of that in the theoretical sense of those hydrogen peroxide systems. So if you'll allow me, I'm going to jump to a different document here. So on the screen, you should see a chart that is a comparison of all the filtration technologies, how they stack up against in the indoor air quality category, energy use category, installation and maintenance, and cost. And so we tried to do, we did this really from a macro standpoint, looking in as a consumer. And what we would do, because we own over half a dozen office buildings, and we have to take care of these ourselves. So we look at it, that employ our staff and employ others. And so we have to, we took a look at all these technologies, and we even made this conscious decision as a committee on how we were going to handle going back in. So in the left hand, you'll see the passive filtration, carbon filtration. Polarized media is electronically enhanced media, not electrostatic. Electrostatic is a pre-charged media, and that's very old technology. We haven't used that for years, but I know that some of that's coming back in vogue today. But this is actually electronic enhanced media, electric. And then we looked at low intensity UV light, high intensity UV light, bipolarization tubes, the old tube technology, photocatalytic oxidation and photocatalytic oxidation of package, as well as the needlepoint bipolarization. So we looked at all these, side by side, and we got all the manufacturers involved with this analysis, and they all this has been distributed a lot. I know it says confidential on it, but I think it's the worst kept secret in town. But this basically goes through each technology and discusses energy use, I call it invasive. Is it going to take a lot to install, take a little bit to install, frequency to service, their warranties, and then the cost and the replacement cost. But then more importantly, from a safety standpoint, it talks about how it filters small particles, how it handles mold or complex structures like protozoa, virus, bacteria, volatile organic compounds. And specifically, the one is formaldehyde, the one that we hear the most, the one that's actually in TVOC, a total volatile organic compound, which is a representative of the VOC family. Odor removal, smoke removal, and then does it generate ozone? That's been a hot topic, and how much ozone. So all this is covered in this chart. I'm going to give this to Ashley, and she can make it available for the team at constituency. Okay, so I should be back to screen sharing. If I'm not, Ashley, just let me know. So the first thing when we took a look at that chart, we just basically took the ones that were in the most green, and we wanted to talk about those in that chart. And so this is one. This is electronically, and we'll take a look at how this technology works. With the black dust ASHRAE 52 test, it was MERV 15, and with the atmospheric dust, it was MERV 16 on first pass. The reason we see a lot of school districts using this kind of filtration technology is because it lasts for a long time. We and the manufacturer guarantee this for 5 to 7 years, and we've seen it last for 9 or 10 years without needing to be changed based on static pressure and dust holding capacity. And so that's been popular, but really because the school district manufacturer is able to use the IAQ method, which is a reduced ventilation method instead of using a ventilation rate procedure to lower the amount of outside air that's needed to condition a school or ventilate a school. So we've seen some of these technologies already being deployed for the past 2 decades because of the IAQ method for ventilation versus the ventilation rate procedure. This is it. This is it. What I would call more in the not light commercial but residential form, where it's used on a flat filter section. And all these results in this chart below were generated by I know by Auburn University, put a lot of time into this, as well as ASHRAE into its effectiveness of these lower micron particles. And we've seen the emergence of utilizing this technology with UV light shining on the media, so for more of like a capture and inactivate for a virus or capture and kill for bacteria and mold. This became a really popular system for the U.S. government when anthrax became a huge biological threat. So this is what the U.S. government standardized for, post offices, the Pentagon, any critical facility that could be hit by terrorism. So they use this because it's a capture and kill for anthrax and capture and inactivate for viruses or any biological attack. So we saw a lot of this emergence, and we also see this heavily in airports and casinos for kind of a knockout for smoke removal. And then we see this a lot of pre-filters for healthcare. We haven't seen this emerge in the education market yet, but it does show some promise. This is just a quick look at what it does for. This is based on anthrax, and this is about 12 years ago. And this is what it does as it relates to capturing the anthrax and killing it, and how quickly it does it. Over time, you can see its reduction is 90-something% after 5 minutes or less. And this is again just that technology. We're using UV lights to shine on the fiberglass charged media. So just to kind of give it from an energy perspective, I always try to make everything in like 15,000 CFM air unit, like that's the magic number for an air handling unit. So 15,000 CFM of electronic filtration is, from an energy consumption standpoint, utilizes about 0.4 amps, 0.5 amps at 120 volts. So it's not a lot. You typically have 120 volts lingering around in a mechanical room anyway for a retrofit. So it just doesn't take a lot of electrical power, so it's not a nuisance to your electrical performance of your building or your consumption. But I want to show you a little bit how it works. In this pictorial, that filtration technology has got a center carbon, and that center carbon mesh is applied with a bunch of voltage, and that voltage actually goes into the fiberglass pads on either side of it, and then the screen around it is the grounding screen, and it charges basically those fiberglass pads 360 degrees to catch particles. And we're going to take a look at a pictorial of it. So this is what a typical passive filter looks like, with small particles come attached to the front face of it. It doesn't load 360 degrees. It just latches the front face. And this is what happens when we electric charge the media. The negatives attach to the positive fiber, the negative particles attach, or the positive particles attach to negative fiber, negative particles attach to positive fiber. we start seeing this happen. So it's starting to load 360 degrees. But what really the phenomenon we get, the reason that these can hold so much dust and last so long, is that the particles start joining together in the bed because they're electrically charged, and then they cling on to the actual fiber itself. And then you'll see towards the end of this animation that the differences between, a charged filter media bed versus an uncharged, and how they all load together, and how you can put so much more particles and dust into that filter bed. And this has been something that it's been around longer, I think, than I've been in the business, which is about 24 years. And so this is basically just showing a picture of the passive filters of what the population typically buys versus electronic filter, and how much dust load over time and pressure drop that you can put in an electronically charged filter. So just to recap of active filter review, we talked about it has a high MERV efficiency. It can be used to reduce outside air, which I don't think is going to be a very popular solution moving forward, but it can be if you're using the indoor air quality ventilation method. Very low pressure drop, and it'll last a long time. But again, air has to get through it. It's not doing anything, in the space. So we're going to talk about disinfection here, and what disinfection in a couple of different modes of disinfection. We're going to talk about UV light and really needlepoint bipolar ionization here. And we're going to touch quickly on surface disinfection versus airstream disinfection, because most of the applications of UV have been for surface disinfection for coils and drain pans, and not for airborne disinfection. And we'll take a look at what that is. Also, photocatalytic oxidation, which is deemed in the residential market as an air purifier, is another form of disinfection that uses UV lights as its primary source to energize a catalyst. But for the purpose of this presentation, the reason I don't talk about PCO, it's the most expensive of the three, and so I have to make this presentation within the allowable time. So I didn't address PCO here, but happy to talk about it during the live Q&A. All right, so ASHRAE finally took a position on July 27th on UV light intensity. I saw several proposals going to a lot of our clients that were from effectively Billy Bob's AC, that were pushing just low intensity UV light for coil cleaning, which it does great for coil cleaning, but as air passes by that UV light, it doesn't do anything with it. It only cleans the surface of a coil, and it takes several weeks to get it done. And that's we call that 50 or 100 microwatts per centimeter square, and this is microjoules is in dosage. And then when you talk about disinfection, we've been told that it's typically a minimum of 2,000 microwatts per centimeter squared, but ASHRAE came out and suggested to use 1,500 microwatts per centimeter squared, or we'll put it in, in our terms, 30 to 35 watts per square foot of coil surface. So 15,000 CFM coil will have 30 square feet, give or take 30 to 35 square feet. So just multiply that times, 30 or 35, so you're at 1,000 watts per square foot. And that amp draw is typically 10 to 12 amps all the time, but it takes a significant, now we'll probably have to get another 120 volt circuit. And when we think about applying UV lights, not for disinfection, but for airborne disinfection, we're traditionally used to seeing our UV lights in our air units maybe at 15,000 CFM with 2 or maybe 3 rows of UV lights. So start thinking about 12 rows of UV lights or 10 rows of UV lights. So this high output or high intensity UV light is effectively creating the sun inside the air handling unit, but it is very effective, and there is research and promise that it does on the fly during that 0.3 to 0.5 seconds does inactivate viruses and kill bacteria. So there is a lot of research. It's been around the longest out of all the technologies, but it comes at the cost of applying it correctly. I should say, that's not the right number there, but it comes across of applying it correctly in its intensity. So 30 to 35 watts per square foot, or 1,500 microwatts per centimeter squared. So that's just, something to think about when we're applying this technology. Here is that epidemic task force document telling us the objective measurement. So we're moving on to bipolarnization. And bipolarnization, for us, we've been around and represented bipolarnization since the late 90s, either in a tube type scenario or in this needlepoint brush scenario. Sharp Electronics is probably the largest company, and we'll take a look at how long they've been doing it, that manufactures bipolarization products. But anyway, this is just a pictorial of how it works. And there's many videos on there's so many YouTube videos or videos on the internet that you can go see how it works. But it effectively surrounds a pathogen and starts robbing the pathogen of hydrogen, nitrogen, or whatever elements it needs to replicate or to survive. And it attaches other particles to it. So it's agglomerating particles, just like we saw in that pictures, and it's robbing organic compounds of basically their nutrients to survive. Ions are everywhere. They're outside. We have ion counters. We do a lot of ion counting. We have for the last decade, and we typically see ion in a space where there's not ionization around 200 to 500 ions per cubic centimeter. Then when we need to deplore these systems, we see 5,000, 6,000, 7,000. When I take the ion counter, when I take the family skiing, I see 5,000, 7,000, upwards of 15,000 ions per cubic centimeter. If you're hiking in a waterfall or by the ocean, you see an increased ion count. So this is just what it does objectionally with an ammonia molecule, which is really objectionable by smell. It breaks it down into its simple elements, nitrogen and hydrogen. And then they just break down in order to put what's already in the atmosphere. So it breaks down carbonyl molecules into something that is something that we're happy to breathe or happy to have in our atmosphere that's not harmful. There's been a lot of to do on this, and I want to just simply address this. There's been the EPA monitors ozone, and the EPA has continued to curb the ozone level down. And the reason the EPA monitors ozone is because of pollution and traffic and cars, and it's increased our cars' efficiency because they put mandates on states to lower your pollution, and so it's and a lot of that's in exchange for federal funding for highways. So there's a lot of complicated and intricate government control of how that pollution is accounted for and how federal dollars are doled out, to those specific areas. And so ozone's measured, and ozone has been shown from NIOSH, OSHA, the National Resource Council, which is the equivalent of NIH of Canada, the CDC, the Public Health of Canada, elevated levels of ozone. And it says basically 100 parts per billion or 80 parts per billion, and the OSHA or NIOSH is not good. And so the whole idea of ozone is we just don't want to create any more that's in the air already. So we're trying to lower the amount of total ozone in the air, outdoor and indoor. So we want to use devices that don't create ozone. And so that's basically what this UL standard is whatever electric device, a vacuum cleaner, a dishwasher, a refrigerator, a UV light, bipolarization, whatever's used where people are, we don't want it to create ozone because we know that increased ozone levels is not good for a respiratory system. And so I always say, the benefits of anything, bipolarization, UV lights, electronic filters are ruined if the device actually adds ozone to an already complex air mixture. And ASHRAE recognized that last year in the latest ASHRAE 62 document, said anything that's an air cleaning device, anything has got to be UL 2998 listed. Okay, so this is just quickly a recap, and this is what it looks like in an air handling unit. You'll see up here this needlepoint bar, and down here the brushes on top, which emit the artificial ions, the positive and negative ions. And this is what's used to effectively clean the air from what's ever in the air to break it down into non-harmful constituents or non-harmful compounds. So also in this, whenever we see our clients, and a lot of our clients purchasing these systems, because we're seeing the deployment of lots of these, just for us, and I can't speak for the whole industry, just since March 15th, we deployed probably 150 million square feet of this, if not 200 million square feet, just here in Texas, of these systems. And so what we have to look for is output, because what we're trying to do is create as much ions as possible. So in the space, we've got enough ions to do what they're supposed to do. So there's no sense just adding ionization without understanding that you have to have a quantity of it in order to perform its job in the space. There's already specifically this company called Global Plasma Solutions has got a lot of research they've already done with SARS-CoV-2 virus with the U.S. Air Force and the FAA. And there's a lot of those research papers being circulated already around the internet. There's actually more coming that show concentrations inside the space versus how effective the ionization works against SARS-CoV-2 and other viruses or bacteria. So this is just an example of some of the research that both Sharp and Global Plasma Solutions have paid for over the years, and basically how over time with ionization, it deactivates viruses and deactivates or kills bacteria. And you see here swine flu in here, several viruses, SARS, MERS, tuberculosis. And then the one that popped up is just the latest of SARS-CoV-2. And there's going to be more of that following. There's going to be more of that following for a lot of the industries. A lot of the industries get their hands on, tubes or petri dishes or whatever of the virus. So ionization, although people have asked, how long has it been around? I'd suggest you don't do this because you'll get a lot of cookies on your computer. Go and investigate the residential air purification business. So this is a large industry. It's larger than just the filtration business that we know about. American Air Filter, Farr and Flanders are three kind of big filter manufacturers and what they do a year. The air purification business is 5 times as large, and 45 million units of ionization are shipped per year. And all these people on the right are players in that business, but there's actually about 100 more players in that business. But this slide would look really busy, like a NASCAR jersey if I put them all in there. And then don't forget about the hair dryers. If you go buy a hair dryer that gets your hair dryer faster, it's going to have ionization inside the hair dryer assembly. So I didn't realize that we owned a couple at our house, during all this. So that ionization, again, has just been around for a long time. Some of the school districts and university have really latched on to the research data that's been published here. And this is just quickly talks about if you have an existing MERV filter, using a MERV rated filter of, whichever one, MERV 6 through 17, and you apply high intensity UVC or bipolarization, how much more effective it is at controlling a 0.5 micron particle, which is a SARS virus. So this has been, this has been published for about 10 or 11 years. So this is, again, it's not new. It just is with SARS-CoV-1, not SARS-CoV-2. But again, like I said earlier, it's 96% the same in its makeup, molecular makeup. And the ASHRAE really was a big part of funding some of the research for the high intensity UVC, and the National Research Council of Canada was the one that did the ionization. And both of those are out. Those studies are out and available. But it just goes to show that when you apply these technologies, and we'll call it in series, like a MERV 13 filter with high intensity UVC, you have a much better chance of capturing those small particles, or a MERV 13 filter with bipolar ionization. The system is more effective at controlling the particles. This is just Blue Heaven, again, as I talked about earlier, is ASHRAE's testing lab, and this was a MERV 8 plus needlepoint bipolarization against a MERV 13. And it basically shows, again, over time, that the MERV 8 plus ionization actually performs a little bit better on small particles than MERV 13. And so this is, this was done, looks like in 2017, but this was done in really when we were talking about SARS, swine flu, MRSA, all those. So this has been around a while, and some of the education facilities use this as a technical means to do what they do. And so after I want to just before I close this out, I really want to talk about just measurement and verification. The reason is because it dawned on me, during this time that most, up to this point, 12 years of selling high intensity and low intensity UV systems, photocatalytic oxidation, bipolarization systems, active or electronically enhanced filtration, carbon filters, all these over my life and over our company's life. No one really measures it after. No one really measures the air quality to know, is it working? Is it good? And so this is just, this is basically just the beginning of measuring. This is a bipolarization example. You're measuring the ions output because you're buying this technology because you believe that the ions are going to be good at controlling the airborne pathogens or surface pathogens in the space. So you need to know if it's working or not, versus just buying it and trusting it. And so this is what we've seen a lot of clients do, either put it in a ductwork or put it in a space and attach it to a BAS system, so they can get a rough idea of how much ions are in the space, or just an ion detector to say it's on. So these are, just some couple things to think about is, okay, we bought it, okay, we haven't bought it, and we might want to buy it, but let's know where we are now, and then try to go somewhere we want to achieve is what I try to get, talk to clients to, is that, don't just go buy this stuff, any indoor air quality enhancements, just figure out where you are now, and then, maybe use the right technology for that particular application. So this is basically a typical industrial hygienist example. And so I hired an industrial hygienist for my home when it flooded, and I put in all sorts of technologies to test, because I had an empty gutted home and I wanted to do a lot of testing. And so this is just at a much larger level. This is at a university in Tennessee. And I thought this was timely because I did this just recently in June. And again, this is published all over the internet. And they were comparing the photocatalytic oxidation, which uses UV light, versus needlepoint bipolarization, and a before and after in different buildings, and showing the total particle count, mean volatile organic compounds, and airborne fungi. And so this is pretty much what industrial hygienists and what they bring whenever they do these before and after. And so, industrial hygienists, for a study like this would be anywhere from $3,000 to $6,000 to come out with all the instrumentations, take all this, do the study, do the report, and publish the report. And then you're not seeing, a 10-page discussion behind it. But this is a good example of what before and after is deploying technology. Or there's technologies out there that actually do this real time, in a thermostat. And there's a company. This company is called Senseware. That it's taken me years to find a company that will measure all the particulate matter, carbon monoxide, carbon dioxide, formaldehyde, ozone, and lay that up into a BAS system or external air quality monitor or dashboard. And so it's just this technology is available out there. I think this technology is emerging or growing. I'm seeing companies like Siemens get into this space with more of an air quality measurement device versus just temperature or just a CO2 sensor. So we're seeing a lot of advancements in this device. But this is another example of taking something that, where are you at today and where are you trying to go with indoor air quality? And, this is this kind of technology can take it, a whole nother level into ventilation performance index, air change rates, bioaerosol threats. So this can really start, going a bunch of different directions when you get into this. So really, when we come towards the conclusion of this, all I want to share is basically what's going on out there in the marketplace, from our lens, because we're knee deep in this. We're seeing a tremendous amount of deployment with higher MERV rated filters. That would be the number one most deployed option. We're seeing a lot of folks go and retest and balance their ventilation systems to make sure that they're getting the right ventilation. We're seeing a lot of folks, go to needlepoint bipolarization systems, and filtration or without extra filtration, and also high intensity UV light systems, with or without the increase in filtration. And then on new construction, we're seeing, kind of a take a step back approach and put, some of this more permanent filtration technology that will last a long time and control, pathogens at the surface. So we're seeing, it depends on if you're existing or new construction, because with its existing, you can't put things that are, large. Otherwise, you got to reconfigure, mechanical rooms or ductwork or piping. These are some of the references I used in the presentation, and that's all I have. Thank you guys for listening. I appreciate it, and I'll be here for the live Q&A session to answer any concerns or comments or questions you have. Thank you.
All right. I hope I didn't put everybody to sleep.
You don't have your coffee in your shot this morning. Oh, there we go. There we go.
Brand.
So there are a few questions you answered through the chat, but I'll go through. Aaron Time said, what standards should be followed to ensure systems like ionization are being designed, installed, and operated correctly? This still seems to be left to the discretion of each vendor with little oversight for QA and QC.
It's an awesome question. So the way that I answer this question is I go back and I've done all the research on all the prior testing that's been done for the ion concentration. So it's important when you're evaluating bipolarization vendors to look at what the ion count is per a given area, a given volume, like ion per cubic centimeters, ion per meters. So that what's important is that if one believes the ionization is the right methodology for air purification or air disinfection, then the more ions, the better. So that's really if you take a Texas saying, some is good, more is better. So we typically, the latest COVID-2 testing that's been published all over the internet with the U.S. Air Force and the FAA and the major commercial airlines using a global plasma solutions device is maintaining an indoor environment of around 25 to 27,000 ions per cubic centimeter. And that's a lot. That is a whole lot. And we typically have told people over the years to use anywhere between 2,500 to 10,000 ions per cubic centimeter in the space whenever they're measuring it. Because that was where a lot of the testing was in the past with tuberculosis, anthrax, swine flu, SARS-CoV-1, MERS, MRSA. So that's what we typically tell people is, shoot for an ion density in the space because that's where you want the ions to go. I was in the middle of typing all that, and
much easier to say. Okay, it looks like we have a few more questions coming in. And do you have any thoughts that you want to add to the presentation after you watched it?
Well, this continues to change. There's a tremendous amount of discussion over Labor Day weekend. There was an aerosol airborne conference that I logged into to listen to a lot of PhDs talk about how this is traveling around the ductwork and how they're getting, the pathogens. We need to control pathogens better inside of our HVAC systems and do more ventilation. And so, that's still gaining steam, but there's nothing that's been concrete and published. I don't expect anything for, in the next couple of weeks. But what I do and I answered one of these in the Q&A, how do we control, what's the best way to do it? And we always tell people, there's 4 pillars. There's ventilation control, and making sure you have enough ventilation. So some of the school districts and universities have hired test and balance and commissioning agents, and they're off, making sure all the dampers are open, the actuators work, they're getting enough ventilation in, and that's an excellent strategy. You don't have to use an air purification device. Some folks have upgraded their filters only. So we've seen a lot of different stuff, and I always tell people, which is not good for our company's sales efforts, that we really are the last people to talk to about this. We're kind of, we've got a lot of experts and a lot of engineers that work for us, but at the end of the day, if the temperature and humidity control isn't being handled and you don't have good filtration and, the ventilation is turned off or off, it doesn't, an investment in some of the air purification technologies that we represent and we implement for you guys, it just doesn't work as effective if some of those other items aren't adhered to.
Okay, Glenn Roden asked, he said, "Hey Mike, I may have missed this, but how many models of the GPS actually have the 2998 UL certificate?"
I think I've got Brandon on the phone because I'm on the GPS Advisory Council, and the iMod, which is the one that goes into the what I'd call a commercial air handling unit, that has been UL 2998 forever, and also this one called the DM model. And I know that the FC is in for testing, but I don't think the results have been published yet for ozone generation. I've got one of my someone that's on the call that's a little bit closer to that actual concept. But I can, Glenn, I see Glenn. I can get back with Glenn and give him a specific answer.
Yeah, is it Brandon Damas?
Yes.
I can make him a presenter if you think he'll answer the question better.
Well, I hate to put him on the spot, but please do that.
Okay. So I'll tell you where the post-it chart is while we get Brandon on. Brandon, if you're able to, in the AV pod, turn the red microphone to green, you should be able to talk. Since we're putting you on the spot, hopefully you're there. Marcia, if you go to your session page, which you're probably on right now, if you scroll all the way down, there should be a PDF that says IAQ chart underneath the description and the speakers.
Can you hear me?
Let's see if we can. Yes,
I can hear you, Brandon.
Wow, just throw me under the bus on the spot as we go. So I've heard from them that the official results are coming out, I think, at the end of this month. Essentially, what GPS has told me is that all their products meet the UL 2998, but they only did the test on the iMod originally. But now that since there's a desire to get the UL 2998 for all their products, not only by their customers, but it's also required by code coming out in the latest ventilation standard. So 62.1 has a section that requires 2998 certification for not just bipolar ionization, but any electronic air cleaning device. So they kind of got out ahead of it and have done their testing, and they're just waiting, I think, for the results to come back to publish.
So Glenn also has a follow-up. Are you concerned with a product that only has an 867 certification? And
today. So there was a question before Glenn, but I'll answer the Glenn, and then we'll hop back to this one. So I guess I don't know, right? So I've actually had bipolar ionization in my house for 15 years. I have children and everything. So if I have a problem with 867, there's going to be other issues down the road. and also in our buildings, and also, we've done several ASHRAE articles we've co-authored and published with needlepoint bipolar ionization. That was with products that didn't have the 2998. That doesn't mean that they weren't performing with less than 5 parts per 5 parts per billion ozone generation. And so I don't know. So do I have am I worried about it? I just think with what we know now, and things change over time. It's just the benefits of bipolar ionization, are diminished if it's actually creating ozone, and ozone is one of the things that the EPA measures for air quality. So if it's generating ozone, that's not that's not good for what we're trying to accomplish. But I do want to talk about 867 and 2998 for just a second, because I spent half my day talking to clients about it. It wasn't the concept of generating ozone was not based on needlepoint bipolar ionization. It was based on medical device equipment and really home appliances. And so the history on this is that they didn't, the American Home Appliance Association and the Medical Device Association didn't want initially, before 867 with 50 parts per billion of ozone generation, just didn't feel that, hey, we don't want to put products that you plug with electronics, like a vacuum cleaner creates ozone and a TV creates ozone. Anything you plug in, ozone is a byproduct of that. So you'll see that 867 on really home appliances and things in a hospital. And then, this just got hot. The reason it got hot is because GPS decided to do that 2998 testing, because that was the only way the FAA and the U.S. Air Force would allow the application of bipolar ionization in planes. And so that's where that came out from. It didn't just come out during this pandemic. It started, 5 or 6 years ago. And so that's just, I wanted to give you guys some background and history to that standard and that conversation. All right.
Okay, let's take Lalo's question, and then if you guys, we have to move on to the next session, but if you guys have any questions after we do Lalo's question, they do have a booth, and so you can follow up with Mike there probably, and anybody with HTS with any other questions. So the last question is, what is a good way to figure out what the humidity levels are if we don't have sensors or monitors in the building or EMS system?
So the only thing I can think of that you probably already have is a leaving air temperature sensor off a coil. The humidity in the space follows the leaving air temperature off the coil. So if the leaving air temperature is around 53 or 54, then you can expect to be able to control your space, depending on the sensible heat ratio and load in your space, about 74 and 50% RH. And so if it goes up to like 60 degrees off coil, that would be 74 and like 62% RH. If it was unoccupied, and there was no other latent loads. So you could handle it by that. You could look at the leaving air temperature if you don't have humidity sensors. It's not a great way because it's really not what's going on in the space, but it's a leading measure of what's going to be in the space.
Okay, thank you so much, Mike. And like I said, they have a booth if you guys want to follow up with any questions. This is very informative and very helpful. This recording will be shared, like I said at the beginning, so you guys can watch it again and learn even more. So thank you so much, Mike.
All right, thank you all. Thanks for letting me be a part of it. I appreciate it.
We also appreciate it. And I will see you guys on the next session.